Hi, I'm Winnie. We all know that there are 5 conditions in order to achieve the Hardy-Weinberg equilibrium, which is the no selection, no mutation, no gene flow, large population size, and random mating. So in this video, there are 6 experiments to test the relationship between these conditions and the allele frequencies.
The first experiment is to have a chi-square test on the Hardy-Weinberg equilibrium. The pink one is the recessive while the purple one is the dominant allele. What I'm going to do here is that I'm going to select 50 individuals randomly and sample with replacement until I get my result. The bottleneck effect, we are going to start with only 10% of the individuals and we are going to establish a new population based on the result. After that, we are going to have sample replacement, and again we repeat with the 10% of individuals again until we get a fixed allele. Similar to the previous experiment, the Fowler effect is going to start with 5 individuals too, without sampling with replacement. Then with that result, we are going to establish a new populations and sampling with replacement of 50 individuals. After that, we are going to repeat again, but we are not going to repeat that 5 individuals. We are going to repeat a new generation with the 50 individuals. In the migration experiment, 2 populations is involved. First, we are going to select 10 individuals from each population without sampling with replacement. Then with the result, we are going to establish a new populations with 50 individuals. After record the observation, we are going to re-establish the population based on the new allelic frequencies. The steps are repeated until sufficient information is obtained. In the natural selection event, it is going to start with selecting 50 individuals sampling with replacement. Then after that, 50% of light mice and 10% of dark mice is removed. So in this case, if I want to calculate the allele of the dominant A, it is going to times 2, right? Because there are 2 allele A, dominant allele A in the homozygous dominant. So going to times 2 of how many are there? I believe they has already eaten, so it's going to be 0. And then I'm going to add on the dominant alleles in the heterozygous right here. So the predations of 10% is 15.3. Look at here, I didn't times 2. This is because there is only 1 dominant allele A at the heterozygous. There are another recessive allele A at here. I'm going to add on the recessive allele. So what is the number? Same as the heterozygous. Add on 1 more recessive allele A. See, if you have noticed, this is a homozygous recessive and there are 33 of that, but after the predations it only left 16.5. I'm going to write here 16.5, but in this case I'm going to times 2. Why? Because it is a homozygous recessive. The last experiment is an example of a natural selection. We are going to start with selecting 50 individuals with replacement. After that, we are going to remove 30% of the homozygous dominant, 10% of the heterozygous, and 100% of the homozygous recessive. After recording the data, we are going to calculate and re-establish a new population based on the allelic frequencies. The step is repeated again with selecting 50 individuals sampling with replacement until we get a sufficient evidence